Thank you for the opportunity to be with you. This is my second ICAR meeting, and I've really enjoyed the opportunity so far, and suspect the next couple of days will be quite informative as well. The first comment I want to make is a couple of years ago I got to know Dr. Wickham at the ICAR meeting, and he took me through the process of your animal ID system and your piggyback onto that in terms of collection of phenotypic data and how that feeds back into your genetic evaluation system. And I've looked at that with admiration. We struggle in the U.S. to capture lots of data through our commercial sector, and part of the reason we struggle with that is we don't have an animal ID system in place. So hats off to you all for making efforts and collaborative efforts, that is, to make that system work. I think it's an envy of a number of animal breeders around the world. So with that said, I want to spend a little bit of time talking about a new program that a number of us are involved with in the States to tackle the problem of genetic improvement of feed efficiency in beef cattle. And the first thing I want to do is recognize the collaborators on this project. Certainly it's been, we're just starting year 2 of our project, but it is a collaborative effort, 20 investigators across 10 institutions. And so as you might imagine, sometimes it's a little challenge to keep the communication stream going, but our group has a long history of working together, and we continue to strive to make improvements in this topic and a number of others. But you'll see through that list, Iowa State, Texas A&M, University of Illinois, Minnesota, Jerry Taylor at the University of Missouri is the project director. I'm at Kansas State, University of Nebraska, Dr. Spangler. Gene Seek is involved in the project, a couple of USDA entities, and a couple of researchers at Washington State. One of the really interesting aspects of this particular project is, although it's a genetics project, it includes scientists across a spectrum of disciplines. And I think that's one of the things that's made it really interesting, and hopefully will make it successful, in that we captured lots of ideas from lots of different perspectives to move the project forward. A quick overview of the talk today, just to kind of orient us and give some flag posts as we move along. We're going to talk about feed efficiency as a trait of economic importance with some context to our production system in the United States. We'll talk about trends in feed efficiency and the changes that have happened over time in our production system. And then finally here, an overview of the project and maybe a plea for collaboration, okay? So why is feed efficiency important? Well, in our production system, feed efficiency costs have historically ranged between 50 and 70% of the cost of production in our beef enterprises. And certainly over the last few years, with a dramatic change in our grain prices in the United States, we would probably exceed the 70% mark. Corn still trades for over $6 a bushel in the United States, and is one of the principal feedstuffs that we use primarily in the in the finishing phase of our business, and so that continues to make it really expensive. Feed efficiency has a huge opportunity to reduce production costs in our system. And even modest reductions in feed efficiency, or modest improvements rather, decreases in feed consumed, even in just the feedlot sector of our business. So about a 10% or 2-pound decrease in dry matter consumption we feed about 27 million head of fed cattle in the United States, would result in about $1.2 billion in cost savings. Okay, a huge number, and it doesn't take a lot of rocket science to say, okay, we've got a $5 million project at play. The potential return on that investment is pretty dramatic. So we're motivated to make those improvements. Certainly, more and better stewardship of the resources we have at play not only enhances profitability in the United States, but also helps both food security in our country and around the world. So understanding the components of feed efficiency is one thing that I work primarily in an extension role, helping producers and other educators understand a variety of beef production concepts. And one of the ones that we struggle with is helping folks understand feed efficiency and the different contexts feed efficiency takes as you move through the beef value chain in our country. And one of the challenges of that is helping people understand sort of the two different places where feed efficiency might occur physiologically in animals. And one of those is obviously animals may have improved ability to digest feedstuffs or absorb nutrients from those feedstuffs. And the second area would be potentially, and these aren't mutually exclusive obviously, there may be an opportunity for animals or discover animals that are more metabolically efficient. They do a better job using the nutrients that they absorb through their digestive systems. And that's a challenge to help understand as we move through the project where we're finding these improvements in feed efficiency, and we hope to capture obviously improvements at both places. The other bit is understanding the context of efficiency as we apply it to the beef value chain. We have a tendency in our country, and I would suspect producers and a number of others struggle with this. We get very focused on particularly output traits in our system because they're typically pretty easy to measure. Things like weaning weight, yearling weight, other carcass parameters. That's fine, but we need to start to do a better job documenting the cost side of our production systems. And so as we talk about feed efficiency, there are multiple interventions that we can take to change that trait. One of them is understanding maintenance efficiency and what that means in our production system. As an example, about half the calories consumed in beef production in the United States go to maintenance of our cow herd. So, the amount of nutrients that actually go to producing saleable product, only about 20% of the calories. And so understanding that as a balance becomes very important. Also understanding the differences between individual animal efficiency measures in terms of how they utilize nutrients versus production level or herd level metrics that determine profitability at the enterprise level. Okay, so things like weaning weight per cow exposed that capture a variety of production parameters at the farm level, including reproductive rates, calving rates, calf survival, all of those things that are a function of the nutrients absorbed on that particular farm or ranch. And certainly we can talk about individual cow efficiency measures in terms of her reproductive record over time. So one of the challenges is helping people understand when we talk about efficiency, what is it exactly that we mean? For this particular study, we were focused on efficiency of feed utilization and right or wrong, primarily concentrated around growing animals. Okay, that's our first step, and we recognize that doesn't capture all the differences in efficiency we want to over time, but this is our first stab. This is a plot that represents the rate of change of feed conversion ratio, which is a commonly reported piece of data in our business, and it's feed consumed per pound of gain on a dry matter basis, and you can see a slight downward trend, about 0.5 of a pound per year. This improvement results in about a 1 pound improvement over a 20-year time frame. Not very impressive, is it? And most of this change has been driven just by changes in mature size or growth rate of animals as we dilute maintenance through the feeding period. Here's another slide from a different data set, suggests maybe a slightly lower or less change over time, about 1 pound in 30 years. So we've not made dramatic changes in this particular trait. But of course we haven't had many tools to use to do it. This is feed efficiency from a large data set collected in Kansas and looks at sort of kind of gives you the seasonal variation across years. The big blip here was a really bad blizzard and snowstorm in western Kansas where our feed yards are located. But some downward trend, but certainly represents some of the variation we observe and hopefully some of the opportunities we have to seize. Undoubtedly, the rate of improvement has slowed. We've changed in our production system. We've become very acutely aware of the costs of maintenance of large body weight cows and high lactation potential cows. And so there's certainly some discussion about changing some breeding objectives relative to our cow herd. And so maybe less emphasis on growth performance through our genetics. Recognizing, though, that the genetics associated for direct selection of improvement in feed efficiency are largely untapped. We haven't had any tools available either in terms of EPDs or DNA markers to make improvement in those traits. So again, we think there's a big opportunity for improvement. One of the challenges we've run into, and I suspect producers in a number of other countries, is what is the parameter or the piece of phenotypic data that is the appropriate one to use in a genetic improvement system. And this is just kind of a laundry list of some of the traits that are reported across our business, and we'll talk maybe real quickly about a couple of those and maybe some of the challenges that they present. One of them's a feed to gain ratio, and certainly a lot of literature to support the complications associated with selection of either ratios. So from a genetic perspective, it's very difficult to know and control which either the numerator or the denominator you're making genetic change in, and that presents a problem, particularly in these kind of growth ones. We've seen over time the consequences of selection for either feed to gain or average daily gain typically results in larger mature sizes and leaner body types. In our production system, from the cow side particularly, those are both detrimental things. We don't necessarily want bigger cows, and we don't want harder fleshing cows. We want cows that are more adapted to a production environment that's primarily a grass-based one. Residual feed intake, certainly a novel and relatively contemporary parameter that tries to correct for some of those problems with either average daily gain or feed conversion ratio or feed efficiency per se, in that it corrects for differences in gain and metabolic body weight to try and get more of a clean and pure measure of efficiency. One of the challenges with that in our country is a variety of stages of growth sometimes that data is collected over, and certainly differences in composition. A number of studies look at sort of a residual analysis of those RFI parameters and suggest maybe additional 10% of the variation that exists in those is accounted for by differences in body composition, so intermuscular and subcutaneous fat, which obviously biases the parameter. And from an animal breeding perspective, one of the challenges with residual feed intake is that since it is a statistic residual, all of the errors in the model that we're looking at land in the piece of data we're trying to use for selection. And I don't know about the rest of you, but that seems problematic to me. And so we're trying to work through, how do we use RFI as an instructional tool and maybe as a phenotype to evaluate animals versus how do we include that data or other pieces of information in our genetic evaluation system to make progress. Okay, and so one of the obvious ones that's not on this list here is obviously just gross feed intake. And one of the strategies I'll emphasize to you later is that gross feed intake and including gross feed intake into an EPD calculation and subsequently a selection index provides lots of flexibility for a variety of production and breeding objectives. Okay. So quickly on to our project. I want to try and get us a little bit closer back on time. So we'll talk about this project real quickly. Again, we're in year 2. The project started in April a year ago. It's funded on an annual basis up to about $1 million. One of the interesting things about this project and a number of others initiated in the United States recently is it's what we call an integrated project. So it has a required commitment to not only basic research and applied research components, but also extension and outreach. So helping transition the technology and information from the laboratory and genetic evaluation systems actually out to producers. And that's a really important component. We've seen lots of technologies developed in our country that get bookshelved and never make it out of the laboratory. And USDA is taking a very active role in trying to get these technologies directly delivered to our clientele. To that end, the demonstration project in this particular grant includes 24 collaborating seed stock producers across 7 or 8 major U.S. beef breeds and a commercial feed yard to actually help producers understand both genomics technologies as well as feed efficiency metrics and how we can deploy that technology across the beef value chain. One of the objectives in the project, obviously, if you're going to do a genomics project, is you got to have a big number of genotypes. And one of the key things that I think helped make this project successful early on was a collaboration with a number of entities that had a lot of legacy data in terms of feed intake records and DNA samples and genotypes already in hand. So that's allowed us to limit the number of dollars that we have to deploy against genotyping either at the 50K or 770K level. Certainly we'll do a lot of that in the project, but if you're talking, we're actually targeting now about 10,000 animals genotyped. If you do the math on that number alone will exceed our budget. So we've been very fortunate to gather up lots of data from existing sources. The breeds involved in the project include Angus, Red Angus, Simmental, Gelbvieh, Charolais, Hereford, Wagyu, and Limousin, so a pretty broad representation of both biological type and the popular breeds in the United States. Some of the research objectives, and we won't spend a lot of time on these other than to highlight a few of them. Obviously, a large genotyping QTL genome-wide associations study project. We want to develop this national cross-breed genomic selection program. So we want to be able to identify markers that work across breeds when possible. And certainly one of the things we're trying to do is understand a bit more the interaction between diet energy density specifically and genotype. So there's a couple of pieces of the project that look at sort of a reciprocal feeding trial where animals are on high or low concentrate diets and flip-flop those to understand that particular interaction. We want to evaluate some of the microbial populations that exist in these animals to help understand the symbiotic relationship between host and that microflora population. Certainly there's some data from both human medicine and some other fields that suggests a genomic level of control of the relative frequency of those various species. And certainly we know, particularly in beef cattle, some of the methanogenic species represent a loss in metabolism, in that methane gas is an energy sink and a carbon sink that we lose. And so if we could select animals that do a better job of controlling those methanogenic species in the gut, maybe those calories would be used for growth and performance. Okay? Other components look at differences in both mitochondrial and nuclear genomes and how those differences are associated with differences in feed intake and efficiency. And certainly a detailed evaluation of these RFI cattle. RFI, I think, represents a very interesting phenotype from a science perspective and may not, again, be the one that we deploy at the end of the project, but certainly from a research perspective, one that's very, very interesting. Some of the extension components, so again, it's an integrated project, and we're very committed to helping producers understand and adopt genomics technologies in the United States. And certainly one of the traits we think will benefit largely from a genomics effort is feed efficiency. Certainly some other traits, I know Allison's involved in a BRD, an animal disease project, another one that's very expensive phenotypes, big impact on our business. Reproduction's another set of grants that are in the current process of panel reviews to fund. And so genomics naturally fit to those traits where they have very expensive phenotypes that are difficult to measure. And we want to translate that into our extension program to get, our stakeholders are involved very early in this process, and in fact help design some of the components of our program, both on the research and extension side. We've tried to engage all segments of the business, so we go clear from the seed stock or bull producers, clear through the commercial stock or feed yard and packing sectors in our advisory and demonstration projects. Large industry education outreach component that includes segments on a nationally televised agricultural TV program. So kind of trying to span as much producer content and clientele numbers as we possibly can. This is just a map of the demonstration project participants, primarily concentrated here in the high plains of the United States. Most of the feeding in our country occurs sort of in this area, but the cattle flow from these states obviously down into Nebraska, Kansas, Colorado, Texas, and Oklahoma for feeding. And so we also have a number of the collaborators in the project come from these institutions and states, so it's a pretty natural fit. Just a real quick, oops, excuse me. That one's more detailed than we need for today. One of the components we do recognize, though, in the United States, like many other countries, there's a small group of animals that represent basically the nucleus herds and seed stock herds. And Robert mentioned in the United States we've got maybe 700,000 or 800,000 cows involved in that production segment. And there's about 28 or 29 million beef cows in the U.S. And so the market target is very different. If we think about a genomics company selling products, would you rather sell to a less than 1 million audience or a 27 million audience? And we think there's a huge opportunity for marker-assisted management as it comes to a number of sort of moderate to highly heritable traits, heritability of feed efficiency, somewhere in the 0.3 range, so as good as most of our growth traits. a big opportunity to do some work in terms of sorting animals into outcome groups, whether that's changes in diet, changes in management through the feeding sector. And so one of the things we want to do at the end of the project is help deploy and develop some of those marker-assisted management tools to commercial producers and feed yards to help kind of illustrate how that process might work and initiate a dialogue there. We've got an advisory board that meets annually that provides feedback to our group, but certainly that's not an asynchronous activity. We want continuous feedback, and so certainly over the next few days I hope some of you come and offer ideas for our project, and I'd love to have conversations with folks that are doing feed efficiency work in other countries. One of the things that our group is very open to are collaborative activities in terms of sharing genotypes and phenotypes from a number of countries. Have already started some of those dialogues, and certainly we'd welcome more of those because it's a big project, and we'd like to be able to leverage those opportunities as best we can. If you want more information, we have a website. It's just beefefficiency.org or ORG, and we'd welcome you to visit that. We're going to have a variety of our both research results in terms of papers and other presentations on there, and already a lot of extension materials already posted on that site. You're welcome to use those and view them as needed, and just look forward to interaction with you all over the next few days. Thank you.